This question is asking, determine and sketch the spectrum of the signal phi of t is equal to 2m1 of t equals 1200 phi plus m2 of t equals 2400 phi, where we know that m1 of t is equal to 10 sinc square times 200 phi minus 50 phi. M2 of t is equal to 5 sinc 240 phi. Okay. So in order to do this problem, first what we have to do is we have to look at the intervals that m1 and m2 begin, because by looking at this equation here we can find out the center of these two, the um, provided diagram. Okay, so here I take this one, the phi of t, 2 m1 of t, and after this first part you have to see the signal. Here we have 1200. We have to see how we can divide into two. So like for example, if I take 2 command, what's going to be inside? That's 600. So the middle of the m1 is going to be located at center of 600. Okay, that's what we can understand from. And then phi t plus m2 of t because here if I take 2 command, it's going to be 1200. So whatever picture we are deriving for m2 is going to be located at the center of 1200. Right. Okay, that's why this equation helps. And then other equation provided that m1 of t is 10 sinc square 205 minus 55, and then m2 of t 5 sinc 245 t. So we have to see what is this in frequency domain. To do that, we have to do the Fourier transform. So first let's go ahead and do the Fourier transform for the 10 sinc square, that's m1. So m1 of t is given by 10 sinc square 205 minus 55, and here we can do one more thing, that is we can take the 205 10 sinc square. If I take the 205 comma, this is going to be just t minus, when I multiply this one with something, I should get 50. So that means um, I have to divide this one by 4 in order to get 50. So this one is 1 over 4. The 5 is already taken. Okay, and this is what's gonna be. And after that, this form is helpful to convert into Fourier transform, because in the Fourier transform we have something like this. We have b sinc square phi b. When you do the Fourier transform this one, you get a triangular. You can just put it like this. Then f over 2b. Okay, over 2b. So what do we have here? We have 10 sinc square 10 sinc square 5 2 5, and instead of b we put the 2, then well, this is just a transfer, like a shift. For the shift we multiply that one with e power minus j25. Okay, so when we do the transformation, this is what's happen. So let's write the equation. 10 square 200 pi t. Let's do that. If we transform this one, this is going to become 10 triangular f over 400. You see, like the value that is multiplying with pi t is the b. So that one is dividing and multiplying by 2. And okay, this is amplitude. I should put s with, so this one is a, this is 10. Okay, this is going to be the Fourier transform, and then there's a shift. When we do the shift, so we have the shift 10 square 200 by 4. So here 1 over 4 shift. So whenever we have a shift like this, Fourier transform, that becomes the e power minus j25f. But based on whatever the shift, we multiply that value. So here we are going to have the exact same thing like this: 10 plus f over 400. That one multiplied by e power minus j25f. And if you multiply minus j25f by 1 over negative 1 over 4, I mean 1 over 4, that is going to become minus j by f over. Okay, so this is what we get. And after that, we can just go ahead and draw the diagram. So here we are going to have a triangular okay. The height is whatever the amplitude we have here, the amplitude and here, and the range is going to be based on the denominator after the f under f. So here is 400, so it means it's going to start from negative 200 to 200. Okay, so this is what we are going to, and now we know the period of this, we know the height of this. We just have to know where to locate it, but we already know that because this is one's m1 of this m1, and m1 is located at the center of 600. Okay, when we draw you will understand better. Now we have to deal with m2 of m2 of t is given by 5 sinc 245 5 sinc 245. Okay, now to do the Fourier transform of this one, we have to be by a. So if you have something like that, the Fourier transform that is rectangular f over 5 sinc 145 Fourier transform 5 over 40. Okay, from this one, 25. So we know that um, the size 40, 45. So 2b is 240. That's gonna be dividing here. Right, f over 240. And for this one, the the amplitude is basically whatever we have here. So put it in the equation, basically over 5 today. Okay, so that one makes 5 over 2b, that is 40. Okay, now we have this equation. From this one, we know the amplitude, that is 5 over 240. And if you simplify this one, that's 1 over 48. And also we know the range. This is going to be the range, whatever under the f is going to be the range. And the diagram for this one is going to be a triangular. I mean, not triangle, but so minus 20, because since the period has 240, minus 22, minus 120 to 120, height is to be whatever the amplitude, that is 1 over 48. Okay, this one is m2. Now we have m1 and m2. Okay, and then we have this equation. We found out where is the m1 located, that is at 600 exactly, and m located at, let me write with a different color because just to indicate where it's located. This is at the middle of, m1 is middle of, so it's at middle of 1200. Based on whatever the range it has, on x like that. If you draw the diagram for this, so first if you look at m1, m1 is the triangular, triangular shape. That's, and it the has totally 400 period. The range, so it means this is located at 600. It's going to be having negative and positive. Let's say this is here, the positive over here, okay, negative, positive square, 5 here, going to be 10, and the range here is minus 200. So you have to look at 200 from this is going to be 8. 200 side is for this one. 200 is 200 from this side is 8. Okay, that is for the triangular shape. That's M. And then we have M2 as well. That is This one we derived that we are at the center of the 1200, so it should be having positive negative aspect, 1200, right? 1200 over here as the height for this one is going to be just 1048. That is less than, it's gonna be significantly like very low, but as it is 48 just for it. Okay, then this one is located at the center of 1200. So here this is negative 1200, positive 1200, and it expands 120 range. So this is going to be 120 higher than, so minus 130 less 120. So this is 10, yes, and 80, 1, 1, 320. Okay, then it, and this is the graph for the 5. Okay, this is the height and range. That's what the question here asks, determine sketch the spectrum of 5T. This they have provided an output. This is how we do this problem. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.